Hi everyone. Today we are going to look at examples of chapter 1, first order ordinary differential equation for BUM2113 Applied Mathematics. Newton's law of cooling states that the rate at which the temperature of a body changes is proportional to the difference between the temperature of the body T and the temperature of the surrounding medium Ts. And the governing equation is as follows. dt represent the temperature of a body changes, okay, proportional to the difference between the temperature of the body, T is the temperature, and Ts is the surrounding temperature. So the rate of change of temperature of a body is proportional to the difference of T minus Ts. Then the proportional sign can be converted into a constant minus K. The negative K is because the temperature is decreasing or cooling. Example, a cup of coffee at 190 degrees Celsius is left in a room of 70 degrees. At time t equal to 0, the coffee is cooling at 15 degrees of Celsius per minute. Number 1. Find the function that models the cooling of the coffee. So the cooling process follows the Newton's law of cooling. Which state that the rate of change of the temperature equal to negative K T minus Ts. So from the problem, a cup of coffee at 190 degrees of Celsius. Let's visualize this. Let's say we have a cup of coffee. It's very hot with 190 degrees of Celsius. It's left in a room of 70 degrees of Celsius. It means that the surrounding temperature is 70 degrees of Celsius. So we can regard this 70 degree as Ts, surrounding temperature. Alright, so here, since we can write as Ts as the 70 degree of Celsius, we can update the equation. It becomes T minus 70. Okay, now we want to solve this. So before we can solve this, we need to find the value of K. Can we find the value of the unknown K here? Yes, by using the information given in the sentence. A cup of coffee at 190 degrees of Celsius is left in a room of 70 degrees of Celsius. So the initial temperature 190 can be written as at t equal to 0, at the beginning, at the initial time, t equal to 190 degrees of Celsius. And also, we have another information here. At time t equal to 0, the coffee is cooling at 15 degrees Celsius per minute. So here we have another information. At T equal to 0, the cooling, which is dt dt, equal to negative 15. Okay, negative because the process is cooling, means that the temperature decrease 15 degree per minute. Okay, where time is measured in minute. So based on this information, we can rewrite this. We can use this equation dt dt, which is negative 15, equal to negative k. T is 190 minus 70. So we replace the value of dt dt and also capital T at T equal to 0. Then we solve this. We obtain minus 120k, and then your k can be simplified as 15 over 120. It also equal to 1 over 8. Now you obtain your k, which is 1 over 8. By putting the value of k, we can update the solution. We can update the differential equation. Now your dt dt can be written as negative 1 over 8 t minus 70. So this is the differential equation that we want to solve. Okay, so this is first order. First order ODE. To solve this, we have three options. Whether you can use a direct integration, or you can use separation of variable, or you can use a linear technique. So the most suitable technique that we can apply is separation of variable, because we can separate variable to each side. What I mean here is I can put the variable of t to the left and variable of small t to the right, like this. We can separate the variables. So we use separation of variable. Now we apply integration on both sides. The left side becomes ln, and the right hand side becomes negative 1 over 8t plus c. We solve this. To remove ln, we write like this. So this, the right hand side can be written as e to the c. If you write a e 1 over 8t, where a equal to e over c. And lastly, your t equation is 70 plus e negative 1 over 8t. So this is your updated function of t. So this is question number 1. Find the function that models the cooling the coffee. So here is the answer. Question number 2.